What up, what up? On Back to Basics today, we're going to talk about factoring. Now, factoring is basically reverse distribution, right? You know distributed property, you have a number attached to a parentheses, and you say 3x times 15 is 15x. 3x times 2x, 3 and 2 multiplied to make 6. X times x is x squared. That's distribution. Now, factoring says, I'm going to give you this guy right there. I want you to make it look like that. So basically what we need to do is it's two parts. We need to look at every term inside the parentheses. What number can I divide out of each term? What number can I divide out of each term? The largest number that I can divide out of each term, so 3. And how many, or what's the largest amount of letters that I can pull from each one? I can pull an x from here, I can pull 2 x's from there, but the largest I can pull from both is just 1x, so 3x. Once you do that, what's left over is you divide the coefficients, so 3 divided by 15, or I guess 15 divided by 3 is 5, and you subtract the exponents. If I take away an x from an x, I have no x's. If I divide 3 from 6, that's a positive 2, and if I take away an x from an x squared, that leaves me with just an x. So factoring is that. You look at your polynomial, you look at the numbers separate from the letters, and you say to yourself, what's the largest number I can divide from each number, and what's the most amount of letters I can take from each term? And then you pull them out, and then you see what's left over. So here we go. Let's just get started. Okay. We need to figure out what is the largest number that I can divide out from each of these. I have a 9, I have a 3. The largest number I can divide from 9 and 3 is 3. In each term, I have x's. What's the largest number of x's that I can pull out of each term? I have 2 here, I have 1 here, so the largest number that I can pull out is just 1x. Okay, now inside the parentheses, I have my leftovers. 9 divided by 3 is 3. If I take 1x from 2 x's, I have 1x left over. If I have a minus sign, 3 divided out of 3 is 1. If I take out an x from an x, I have no x's, so I'm not even going to put anything there. So essentially what I have is if I were to distribute this out to make sure I did it right, 3 times 3 is 9, x times x is x squared, 3 times negative 1 is negative 3, and x times negative 1 is still negative x. I did it right. Okay, let's do another one. I have 2 terms. I'm going to say what is the largest number I can divide out of each term, and it looks like 4 is the largest number that I can divide out of each term. I can't do 6, I can't do 8, so it's 4. What's this largest amount of x's that I can pull out from both of these? Well, I have 2 here, I have 1 here, so the largest amount of x's that I can pull out of both is just 1x. Now my parentheses is going to be the leftovers. 12 divided by 4 is 3. If I remove an x from 2 x's, I have 1x left over. Drop down the minus sign. If I divide a 4 from 16, I get 4. If I remove 1x from 1x, I have no x's left over. I'm done. To check my work, 4 times 3 is 12, x times x is x squared, 4 times negative 4 is negative 16, x times nothing is just an x. I did it right. I did it right. What's the largest number that I can divide from 8 and 16? 8. Each term also has an m. What's the largest amount of m's that I can divide from m cubed and m squared? Well, I can pull 3 from here, but I can only pull 2 from there. So the largest amount of m's that I can pull out is m squared, 2 of them. Now there's a third thing here, an n. But you don't have an n. So I can't pull out a common factor using that n. So can I pull out a common thing? No, n is just there. So what's my leftovers? Well, if I divide 8 from 8, I get invisible 1. I'm going to hold on to that. If I take m squared from 3 m's, I'm left with 1m. So that invisible 1 is there, but I don't need the invisible 1. If I divide 8 from 16, I get 2. If I pull 2 m's from 2 m's, I have no more m's. And I have nothing here, so I have like this little n just kind of floating around. That's my leftover. That's my answer. So to check my work, 8m squared times m is 8m cubed. 8m squared times 2n is going to be 16m squared n. I did it right. One more. Now I have 3 terms. Still one letter, but 3 terms. What is the largest number I can divide from 4, 2, and 8? I can divide each of these by 2, but that's the biggest number I can divide, so I'm going to bring out that 2. Everything also has a b. What's the largest amount of b's that I can pull out from each of these? I have 3, I have 2, I have 1, so the largest amount of b's that I can pull out from each of them is 1. Now to do my leftovers, my scraps. 4 divided by 2 is 2. If I remove a b from 3 b's, I have 2 b's left over. 2 b's, or not. It's 2 b's. It was a Shakespeare joke. 2 divided by 2 is invisible 1. I'll hold on to that. If I remove a b from 2 b's, I have a b. So invisible 1, b is what's left over there. 8 divided by 2 is positive 4. If I remove a b from a b, that's it. No more b's. Sounds awesome to me. I hate b's. But that problem is the bee's knees. And if I wanted to check my work, 2 times 2 is 4. B times b squared, b cubed. 2 times invisible 1, 2. B times b is b squared. 2 times 4 is 8. B times no b is b. I did it right. 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 That is basic factoring, ladies and gentlemen. Basic factoring. Thanks for watching. Bye.